Imagine a world where massive, highly complex industrial machines can actually figure out exactly what's wrong with them and then, no joke, order their own replacement parts before they even break. Sounds totally like science fiction, right? Well, it's actually happening right now. Let's dive right into this explainer and see how Shell, literally one of the world's largest energy companies, completely transformed their operations using autonomous AI. To understand why this transformation was absolutely necessary, we have to look at their status quo, the brutal, everyday reality of the oil and gas industry. It is a wildly high-risk, capital-intensive environment. Consider this: a single unplanned pump failure at an offshore rig or a refinery that can cost upwards of $10 million in lost production. $10 million. That is a massive financial drain from just one single piece of broken hardware. So this looming $10 million threat, that was Shell's call to adventure. To survive in these super volatile commodity markets, they desperately needed a way to predict equipment breakdowns long before they actually happened. The fundamental question they had to ask was, what if AI could step in and fix the machine before it even breaks? Shell found their crucial assistance by partnering with C3 AI. They deployed C3 AI's reliability suite on Microsoft Azure with one main goal: bringing AI-driven insights directly into their daily operations through predictive maintenance. Basically, this means using real-time telemetry, historical data, and machine learning models to spot emerging risks and prevent failures before things go south. It's kind of like giving the machinery a crystal ball. Now, you might be wondering if this happened overnight. Definitely not. This marked their departure, crossing the threshold into a massive digital journey that started way back in 2018. They renewed their global deployment in 2021 and are expanding into agentic AI through 2026. They took on the monumental task of connecting mountains of operational data across thousands of pieces of equipment all over the globe. Of course, you can't just plug AI into a global energy grid and expect miracles on day one. They faced immediate trials. Think about the sheer challenge here. It's like a giant puzzle. They had to combine super high-frequency sensor feeds with old historical logs, and then train the AI models to understand what normal behavior actually looks like for incredibly complex gear. We're talking massive pumps, turbines, and compressors. But as they approached their operational goals, they actually cracked it. Shell successfully implemented basic machine learning. The system would ingest the sensor data, apply the models, and detect anomalies. Boom. Suddenly, human engineers were getting these early warnings when equipment started acting suspiciously. Honestly, it was a massive leap forward at the time. But then, disaster. They hit the darkest point of this journey, the crisis of the last mile. The AI systems were successfully predicting failures, sure, but human engineers were suddenly completely overwhelmed. I mean, they were drowning in a sea of red flashing lights. They suffered from severe alert fatigue, forced to manually investigate endless system warnings. The AI was finding all the problems, but humans literally just couldn't keep up. And this brilliantly illustrates the real treasure they discovered to overcome this crisis: a complete pivot. They moved away from that basic machine learning, which, remember, was causing all that manual investigation and alert fatigue, and they fully embraced agentic AI. This was a total game changer. It introduced autonomous reasoning, automated workflows, and instant responses. So what actually is agentic AI? Well, it's next-generation artificial intelligence configured to independently investigate root causes, reason through contextual data, and execute complex workflows without constant human oversight. So the absolute crucial point here is that instead of just pinging an engineer with an alert, this autonomous agent actually stops and asks why that alert fired, and then figures out the solution all by itself. Let's look at how this builds, because the process is fascinating. First, the system ingests the high-frequency operational sensor data. Second, it integrates that data with structured financial and business context from enterprise platforms like SAP. Third, the agent automatically investigates the exact root cause of the fault. And finally, it instantly drafts a precise automated work order. It's doing the heavy lifting for you. Now, what's really mind-blowing about this integration is how seamlessly the agent talks to enterprise platforms like SAP. When a deviation happens, the agent cross-references the sensor data, analyzes the recent maintenance history, and get this, it actually goes into the inventory system to verify if spare parts are available. If they aren't, it generates precise procurement requests exactly like a human planner would. It operates entirely within their existing workflows. No new systems to learn. Armed with this incredible agentic treasure, Shell began their return to stabilized operations. But they didn't just isolate this to one single facility. Nope, they scaled this automated response across a massive global footprint, rolling it out to over 30,000 pieces of critical equipment. 30,000! That covers their upstream, midstream, and downstream operations. This initiates their new life. It created a completely transformed operational reality. By letting the AI handle the root cause analysis and write the work orders, the delay between a predicted failure and the actual fix just plummeted. And as you'll see from the results, this predictive maintenance ecosystem slashed unplanned downtime by a staggering 35%. And the financial resolution of all this is absolutely undeniable. Take a look at Shell's return on average capital employed, or ROACA. It saw a massive jump from 7.1% in 2014 to 15.9% in 2022, even with similar global oil prices during those times. AI essentially acts as an operational efficiency mediator here, significantly boosting their capital efficiency and financial resilience, even when the market is going crazy. To put that into perspective, the sheer scale of the financial impact is insane. By ensuring repairs only happen when they're genuinely needed, and just leaving perfectly healthy hardware alone, this new autonomous ecosystem saves Shell an estimated $2 billion. $2 billion every single year. It fundamentally rewrites the economics of running a massive energy grid. As C3AI's president Stephen Aitken points out here, this is exactly what enterprise AI should look like in production. The new status quo completely elevates human engineers. Actually, scratch that. It liberates them. They're no longer bogged down manually digging through endless alert logs. Instead, they become high-level overseers of a highly efficient, automated industrial machine. So, as we wrap up this explainer, we have to ask, if agentic AI can independently maintain a global energy grid, investigate its own root causes, and literally order its own spare parts, what manual bottlenecks could it eliminate for you tomorrow? Think about the last-mile headaches in your own world. The agentic awakening is officially here, folks. Keep questioning what's possible.